This is R.D. Sharma solution, class 12, chapter 3. Binary operation exercise is 3.4. Question number 1. Let star be a binary operation on Z, defined by, how it is defined? It is defined on Z, integers. Defined by A star B equals A plus B minus 4 for all A and B which are belonging to Z. So this kind of question we have already done because there are 3 parts which is being asked here. The first is whether this star is commutative or associative or not. This is the first part. What is commutative? A star B, whether it is equal to B star A, that we have to find out. So this is basically A plus B minus 4. Here we have B plus A minus 4. You can just replace the position of A and B. You get A plus B minus 4 as this here, A plus B minus 4. So they both are equal. So star is commutative on Z. In associative, what does it mean? It means whether A star B star C equals A star B star C when AB is done first and BC is done first. A star B is simply A plus B minus 4. And then we'll do it with C. Okay, C. Here we'll have A star. This will be B plus C minus 4. B plus C minus 4. Now these two. So A plus B minus 4, that is A plus B minus 4. Then we have, this is the first term. Then you add the second term. Then you subtract 4. Similarly here, the first term add with the second term. A plus B plus C minus 4. And then we have a negative 4, minus 4. Okay. So A plus B plus C is there. Minus 4 is minus 8. Here also A plus B plus C minus 8. What do you get? They both are same. So star is associative on Z. Now we'll go to the identity element and then the invertible element. But in order to find the inversion or inverse, we need to find out the identity element. What is an identity element? An identity element, that is, you take any element from this set Z. When you multiply it with the identity element, this identity element should also belong to that set Z. You should get the same value back again. So A star B equals A plus B minus 4. When we do A star C, A star E, what do you get? A plus E minus 4. And this has to be equal to A. So E will be equal to 4. So the identity element is 4 with respect to star. Now we have found the identity element. Find the invertible elements in Z. So we have to find out the inverse now. So Z will be equal to, see, A you take, B you take from here. So A star B and B star A, whichever you do, you need to get E back. Okay, A star B is A plus B minus 4. So you should get E. E we already know. We just found out. It is 4. So take it over here. A plus B will be equal to negative 4 I am taking here. So it will be 8. But what I am trying to say here is B is the inverse. When you multiply A with A's inverse, you should get the identity element. So B is the inverse. Basically, we have to find out what is B. So in this expression, we are interested in finding B. A plus B minus 4, you can take this minus 4 here. You get A plus B equals negative 8 plus 8 and B equals 8 minus A. 8 minus A is actually the inverse of A. Okay, which is belonging to Z. Now question number 2. This is CBSE 2010 question. So Q0 is what? Let's start with a binary operation Q0. Q0 is set of non-zero rational numbers. That is P by Q form with no zeros. Defined by A star B equals 3AB by 5 for all A and B belonging to Q0. A star B equals B star A. For that we will go for commutative. So I am taking 3AB by 5 because in the book it is 3AB by 5. But even AB by 5 also can give C. A star B is 3AB by 5, A is 3AB by 5. They are associative because they are equal. And they are commutative, sorry. Then coming to associative, A star B star C. First we'll do this one. That you will get 3AB by 5. Star C, you'll get, let us do BC first. So BC, 3BC by 5, A is already there. But you get 3ABC by 5 by 5. Here also A, 3BC by 5 by 5. What do you get? 3ABC by 25. Here also you get 3ABC by 25. So this 3ABC by 25, 3ABC by 25. Here you see it is AB by 5. So in certain edition it is AB by 5. But since this in CBSE 2010, it has come as 3AB by 5. So I am doing it 3AB by 5. Right? If it is AB by 5, it will be ABC by 25. There will be no 3 here. So in both the cases, it is associative because both the left hand side and right hand side, they are equal. So CBSE 2010, okay. Next is find the identity element if it exists. So how do we find the identity element? We will find it for AB by 5 and 3AB by 5. Identity element is when you multiply any element taken from the set with this identity element, that element should come back. A star B equals A. So A star B is what? 3AB by 5. So I'll do it for AB by 5 also. So A star B, in this we have to use the B as E. So 3AE by 5. And this should be equal to A. A cancels, E will be 5 by 3. If you are just taking this AB by 5, it will be only 5. So you can take E as 5 or 5 by 3 depending upon whether it is AB by 5 or 3AB by 5. Right? Okay. Now we have question number 3. Let star be a binary operation of Q minus 1. So rational number without a negative 1. You cannot take negative 1. Negative 1 is not possible. That is when you take A and B and the result, it should not be negative 1. Defined by A star B equals A plus B plus AB for all A and B belonging to Q minus of minus 1. Then first is commutative and associative, then identity, then we have inverse. Okay. Let us start with the commutative. Since we have already done this kind of question, okay. In the exercise 3.2, we have done this kind of question multiple times. In the 3.2, you can just revisit how we solve it. I will directly come to the identity part and then the inverse part, right? Okay. Identity element is A star E equals A. So A star B is what? A star B is A plus B plus AB. So A star will be A plus E plus AE. This equals A. A gets cancelled. You have E plus AE as 0. So E plus AE, you can take E common. E is 1 plus A equals 0. So either basically there are two values. So it can be either E equals 0 or 1 plus A equals 0. So 1 plus A equals 0 means A equals minus 1. But since Q minus minus 1 is given, that is you cannot have a as minus 1. So E has to be 0. This is the identity element. Now when we got the identity element, let us see the inverse. So in order to get the inverse, we know that when we multiply a value with its inverse, identity element should come back. So you are taking A from here and you are taking B from also here. They cannot be equal to negative 1. And when we operate them, we should get E. And since we just got E as 0, so we directly replace E with a 0. Okay. So A star B is given by what? A plus B plus AB. So A plus B plus AB, this is equal to E and E is equal to 0. So A plus B plus AB. Now and what we have to find out? We have to find out B. Because B is the inverse. When you multiply A with the inverse, you get 0. That is E. So B we have to find out. In this expression, take B on left and whatever is coming, put it on the right. So B plus AB equals negative A. Take B common, 1 plus A equals negative A. B equals negative A by 1 plus A. This B is actually negative A by 1 plus A is the inverse. I hope you got the idea. Question number 4. Let A, this is from R0 to R, where R0 denote the set of all non-zero real numbers. A binary operation O is defined on A like this. I'll just show you how it is defined. It is defined as AB when operated with CD, you should get AC into C, comma BC plus D for all A, B and C, D belonging to, there is AB also belonging to R0 across R and CD also belonging to R0 plus R. So whether it is commutative or not, whether it is associative or not. When we operate AB with CD, if we operate CD with AB, the same should come. So AB, CD is already given. Let us do it with CD and AB. So what is happening? C should multiply with A. Next is B into C plus D. So here in this case, what we get? D into A plus B. Now you see they both are not equal. They both don't seem to be equal. AC is okay. The second part is not equal. So this is not commutative. Please remember it is not commutative. Let us check for the associative now. Associative is what? A, B, C, D. But we need third term also in associative. So I'll just clear it. We'll deal with A, B, C, D and EF. That is, when A, B operate with C, D, what do you get? A, B and C, D. This is already given in the question. Okay. So you get AC, that is first two you multiply, then you multiply second with the first one and add the third one. So A, B will operate it with C, D and then we'll operate it with EF. I'm taking EF. Next term will be of course EF. So first we'll operate this one and this is already given. AC and BC plus D. So AC and BC plus D and this will operate with EF. So AC multiplied by E, ACE will be the first term. Then BC plus D multiplied with E. BC plus D multiplied by E and then you add F here. Right? So ACE, you have BCE plus DE plus F. Right? Okay. Now we'll do the same thing. First taking CD and EF, we will operate this one. So let me just write it because we are going to operate CD and EF first, then we will operate it with AB. So let me write it again. AB operated with CD operated with EF. So CD and EF first we will do. Okay. So CE, this will be CE. Then we have DE and then you add F. Okay. AB is also there. So A multiplied by CE, then B multiplied by CE, and then you add DE plus F. So BCE plus DE plus F. Okay. Now what do you see here? This term is equal to this term. This is equal, and this is equal. So they both are equal. It is not commutative, but it is associative. It is associative. The next part is we have to find out the identity element. How to do the identity element here? Identity element is when we have some certain A, we multiply or operate it with E, you should get A back. A is what? We have AB. Operate it with E. Now E cannot be written like this. It is a pair. A, B, C, D, E, F, they are pair. So we have to write E as two values. I am just taking E for example XY. When we operate AB with XY, we should get A back. What is A? This is also an ordered pair. So AX and then BX plus Y, this should be equal to A. What is this A? A comma B. I'm writing A as A comma B. So AX equals A. I'm just equating AX with A and BX plus Y equals B. From here you get X equals A by A, that is 1. You get X as 1. And then from here, I'm writing X as 1. So B plus Y equals B. Y is equal to B minus B, that is 0. So this X and Y, that is the identity element. So X and Y we have taken as the identity element. In place of X I'm writing 1. In place of Y I'm writing 0. So 1, 0 is the identity element in A with respect to this operation. The third part, we have to find out the inverse. In order to find out the inverse, if we have A and B, when we operate them, we should get E. But A and B we cannot take. because A and B I can take as A and B. In B we can take CD. There is another way also here, but let us go with the way we understood just now. So AB operated with CD, you should get E. And what is E? 1, 0. This is the identity element. So equate this with 1, 0. Right. So AC, then we have BC plus D. This equals 1, 0. So AC equals 1. Then we have BC plus D equals 0. What do you get here? C equals 1 by A. Now this C equals 1 by A, just please remember we have to find C comma D because that is the inverse. So here put C as 1 by A, so B into 1 by A plus D equals 0, and this D will be equal to negative B by A. So C is 1 by A, D is minus B by A, 1 by A negative B by A, and that is your C comma D, which is your inverse. Question number 5. Let O be the binary operation on the set Q0 of all non-zero rational numbers defined by A operation B is AB by 2, A into B by 2. So Q0 is basically non-zero rational number, all the P by Q forms with non-zero value. So the operation is given as A into B by 2, and this A and B are belonging to this Q0. So we have to find out whether it is commutative, associative, then the identity element, and then the inversion or inverse. So first we'll start with the commutative A operation B, whether it is equal to B operation A. Let us see. A operation B is A into B by 2. B operation A is B into A by 2. So what do you get? They are equal. So this is commutative. Associative A operation B operation C, whether it is equal to A operation B operation C, one at a time, one pair at a time, AOB and then BOC. So this is AB by 2 operation C, this is A, BC by 2. So this is AB by 2 into C divided by 2. Here we have A into BC by 2 divided by 2. So we have a 4 in the denominator, 2. Okay. So A, BC by 4. Here we have A, BC by 2 by 2. That is again ABC by 4 we are getting. What does it mean? It means it is associative. This star on this Q0 is associative, right? Okay. Coming to the identity part. What is identity? In this Q0, if you take any element A and operate with that identity element should also belong to that Q0. The same element should come back. A operation E should be equal to A. Okay. Okay, see, A operation B is given by A by 2 in this question. So we can write AE by 2 equals A. This AA gets cancelled. E goes on the right hand side. E becomes 2. So E equals 2 is the identity element in Q0 with respect to this operation O. Now coming to the inverse. What do we do in inverse? We say if we have an element A and an element B coming from Q0 and the operation gives you the identity element, then B is the inverse of A is the inverse of B. A star B is AB by 2. E is also 2, which we just found out. So we have to find out B. B is the inverse. So B is, that is 4 by A. So B is 4 by A, and this is going to be the inverse of A. Question number 6. On R minus 1, that is all the real number except 1. We cannot have A or B or anything which is equal to 1. So binary operation star is defined by A star B equals A plus B minus AB. A plus B minus AB. Prove that star is commutative and associative. It is commutative and associative. So if you see the exercise 3.2, even this exercise, the question number 3rd, almost similar. So we have already talked about the commutative and associative. So we are not going to do this here again. This will just be a reiteration, but we'll talk about the inverse and the identity. So let us start with the identity. How does this identity come? If A is operated with E, you should get A back. A operated with E, A should be coming back. So A plus E minus A, in place of B I am replacing by E. A plus E minus AE should be equal to A gets cancelled. E you can take common and you can get 1 minus A with E. So E 1 minus A equals 0. That means either E is equal to 0 or 1 minus A is equal to 0. So that is E equals to 0 or A is equal to 1. But as I said, A cannot be equal to 1 because the set is not having 1, R minus 1. So A cannot be 1. So E has to be 0. That is E, which is the identity element, is 0. Coming to the inverse part. In the inverse part, because identity we already got, it's equal to 0. Inverse is A star B, B star A, and then we have the E as the identity element. A star B is the inverse if you get E. So A plus B minus AB is equal to E. E is actually 0 here. So we have, this is minus, negative. What do? We take A on right hand side. So we get B minus AB equals negative A. We don't want this negative, so just replace this. AB minus B will be equal to plus A. Now take B common. A minus 1 you get equals A. B equals A by A minus 1. Okay, this is your B equals A by A minus 1 is the inverse of A in R minus 1. Because if you get A equals 1, take A equals 1, it will be A by 0 and that will not be defined. This is the inverse. Question number 7. Let R0, this denote the set of all non-zero real numbers, and let A equals R0 cross R0, R0 that is, subscript is 0. If star is a binary operation on A defined by, how is it defined? It's defined like this. A comma B operation C comma D is equal to AC, you come A and C first multiply, and second pair multiply B into D. This is what is given in the question. So we have to show this star to be commutative or associative, then identity, then the inverse. That is how we are going to go about it. So since we have this AB cross CD equals CD cross AB, that we have to find out. AB cross CD is already given. So we'll just replace it, CD cross AB. So first pair has to be multiplied, that is first value of the pair, A, C and A. So AC. Then we have D and B, that is B into D. Just write B into D. Okay. So you have both as same. So A star B equals B star A, that is equal. ACBD, ACBD, that is it is commuted. It is commuted. Now coming to associative. Associative means what? A operated by B operated by C should be equal to A operated by B operated C, and we take association. But here we will take pair A, B, C, D, E, F. We are taking E, F. And then that has to be equal to A, B, C, D, E, F, and we'll take pair one at a time. That is, in the first case we'll take A, B, C, D. In the second case we'll take C, D and E, F. So A, B, C, D will give you AC and BD. AC comma BD. And here we have star EF, EF. We have AB. What do you get here inside? CE and DF. CE and DF. Okay. So this AC into E means first value of the pair has to multiply. ACE you get BDF here. On the right also you get A into CE and B into DF, BDF. What do you see here? They are equal. So they are equal, that means they are associative. This operation is associative on this set. I hope you got the idea. Let us clear it and let us come to the identity and inverse part. So identity will be what? A star E equals A. But still we don't have A here. We have a pair. So we'll write A as A comma B. But this E, that is the identity element, will take some other thing like XY. Say it's XY because it has to be an ordered pair. XY operated and it should give you A, that is A comma B. Again A will come. So let us apply A into X, B into Y. This is equal to A comma B. Now just equate AX with A and BY with B. So X becomes equal to 1, A gets cancelled. Y is B by B, that is again 1. So this XY, which is the identity element we are talking, is 1 comma 1. Right? When we have the identity element, now we can go for inverse. So for inverse, what do we do? See, A star B has to be equal to E. B is the inverse of A. If we get E as this result, B is inverse. So A comma B. In the place of B, let us say CD. So A comma B, C comma D. And we operate them. And what we get? E. E is what? 1 and 1. So 1 comma 1 we take. So this is AC. This is AC you get. And you get BD. and this is equal to 1 comma 1 BD. Okay, 1 1 1. So now you equate. We equate AC should be equal to 1 and BD should be equal to 1. We have to equate. So AC equal to 1, BD equal to 1, and since CD is our inverse, we need to find out CD from here. So C will be what? 1 by A, and then we have this D we have to find out. So D will be equal to 1 by B. So 1 by A and 1 by B, this is the inverse of AB for all AB belongs to that set A. Question number 8. This is important. Why? Because this is a NCERT question. Those who are from NCERT, you are also doing the NCERT in RD Sharma. RD Sharma has NCERT inside it. Okay. Let star be the binary operation on n defined by A star B equals HCF of A comma B. Does there exist identity for this binary operation on n? So we need to find out whether this identity element exists or not. This is the question. But just to revise or recall, we know HCF and this LCM. The highest common factor is found by finding all common factor of two numbers and selecting the largest number. For example, 8 and 12. Let us find out all the common factors of two numbers. 8 is what? 8 is, let us find the factor first. 1, then 2, then 4, then 8, like this. We have all of these as the factor of 8. 12, we have 1 and 2 and 3 and 4 and 6 and 12. All are these the factor of 12. And now take the common of these two. So you have common 2 and 4. 2 and 4 are common. In this common, you have to find out the highest one. Highest one is 4. The highest value which can divide both of them. But it has to be common to both of them. So this is the highest common factor. Even the see LCM is also there. So if you multiply HCF with LCM, you will get the multiplication of these two numbers. This is also an identity. Okay, coming back to the question, let E be the identity element. And we know this identity element will only come when we have A operated with that identity element and we get the A back. So A star E, you get this A back. So what do you get? A star is the HCF of A comma A. And you should get always A back. And that is not true at all. You take any value. You take say 2 comma 1 or 5 comma 1 or 13 comma 1 or 13 comma 0, whichever you take. You won't get A back always. You can see very well. So we cannot find E that satisfies this condition. Therefore, we can safely say the identity element with respect to star does not exist in n. That is the logic. If you want, see 1 and 0 normally you get as E. Even if you put 1 and 0 with any of the example taking from the natural number as A, you won't get the result. This is very true. So this 8th question, NCERT question, we will say this E does not exist. There is one more which is the extra question. If you have in your edition, just have a look. So thank you so much. This is all about this exercise. Take care.